Here are 5 things to know about neural networks in under 5 minutes. Number 1, neural networks are composed of node layers. There is an input node layer, there is a hidden layer, and there is an output layer. And these neural networks reflect the behavior of the human brain, allowing computer programs to recognize patterns and solve common problems in the fields of AI and deep learning. In fact, we should be describing this as an artificial neural network, or an ANN, to distinguish it from the very unartificial neural network that's operating in our heads. Now, think of each node or artificial neuron as its own linear regression model. That's number 2. Linear regression is a mathematical model that's used to predict future events. The weights of the connections between the nodes determines how much influence each input has on the output. So each node is composed of input data, weights, a bias or a threshold, and then an output. Now, data is passed from one layer in the neural network to the next in what is known as a feed-forward network. Number 3. To illustrate this, let's consider what a single node in our neural network might look like to decide, should we go surfing? The decision to go or not is our predicted outcome, or known as our y-hat. Let's assume there are 3 factors influencing our decision. The wave's good, 1 for yes or 0 for no. The waves are pumping, so x1 equals 1 for yes. Is the lineup empty? Well, unfortunately not, so that gets a 0. And then let's consider, is it shark-free out there? That's x3. And yeah, no shark attacks have been reported. Now, to each decision, we assign a weight based on its importance on a scale of 0 to 5. So let's say that the waves, we're going to score that one. Yeah, no, this is important. Let's give it a 5. And for the crowds, that's W2. Not so important. We'll give that a 2. And sharks, well, we'll give that a score of a 4. Now, we can plug in these values into the formula to get the desired output. So y-hat equals 1 times 5 plus 0 times 2 plus 1 times 4, then minus 3, that's our threshold, and that gives us a value of 6. 6 is greater than 0, so the output of this node is 1. We're going surfing. And if we adjust the weights or the threshold, we can achieve different outcomes. Number 4. Well, yes, but number 4, neural networks rely on training data to learn and improve their accuracy over time. We leverage supervised learning on labeled data sets to train the algorithm. As we train the model, we'll want to evaluate its accuracy using something called a cost function. Ultimately, the goal is to minimize our cost function to ensure the correctness of fit for any given observation. And that happens as the model adjusts its weights and biases to fit the training data set through what's known as gradient descent, allowing the model to determine the direction to take to reduce errors, or more specifically, minimize the cost function. And then finally, number 5, there are multiple types of neural networks beyond the feed-forward neural network that we've described here. For example, there are convolutional neural networks, known as CNNs, which have a unique architecture that's well suited for identifying patterns like image recognition. And there are recurrent neural networks, or RNNs, which are identified by their feedback loops, and RNNs are primarily leveraged using time series data to make predictions about future events like sales forecasting. So, 5 things in 5 minutes. To learn more about neural networks, check out these videos. Thanks for watching. If you have any questions, please drop us a line below. And if you want to see more videos like this in the future, please like and subscribe.